Hey y'all, it's Jack from the Belmont Math and Science Center. I am a bio tutor, and today I will be showing you a tutor tip that I think comes in handy. Okay, so today we're going to be talking about Punnet squares and a little bit of genetics in general. Most of you, if you were bio majors, are going to have to take genetics your sophomore year or whatever year, depending on where you're at in your journey. But it's some important foundational concepts to have going into it. And also, I'm pretty sure you need to use this in Bio 1 and Bio 2 and all that kind of stuff. So, first thing I want to talk about is that, let's see, we are going to go over monohybrid crosses and dihybrid crosses, along with some terminology that you will definitely find helpful. So first things first, let's say that there is a person who has brown eyes, right? Well, that is what we call a phenotype. A genotype would be they have big B, that could be a genotype, or they have big B, little b if brown eyes are dominant. Well, and a dominant trait means that it is expressed over the other trait. So this can be a genotype for brown eyes. Let's say big B, or little b, resembles or represents blue eyes. So blue eyes are a phenotype, and the genotype would be little b, and that's the genotype. And this indicates that that it is a recessive trait. So if someone asks you, okay, let's cross someone who is heterozygous for both parents are heterozygous for brown eyes. Okay, so both heterozygous brown eyes. So this is how you start a Punnet square. It just looks like a window, that you would normally draw when you were little. And sorry for my handwriting, by the way. It's a little bit, interesting. So if you're heterozygous for brown eyes, that means, oh, you know what? Let's establish something. Heterozygous equals when you have big B and little b. And it doesn't have to be B, it can be anything. But homozygous, I guess, is equal to either big B, or little b. And this is what we would call homozygous dominant, and this is homozygous recessive. I hope you guys can see that. Yeah, and I didn't really spell it, but we'll redo that. Recessive. Okay, so if we are trying to cross someone whose both parents are heterozygous for brown eyes, and we want to see what the chances are that their children will have brown eyes. So what we're going to do is we're going to put a big B and little b there. That's one parent. And a big B and little b here. Now, to fill out a Punnet square, you just add whatever's in the parent spot to the boxes. So here we would have big B, big B, little b, big B, little b, and little b. So if we're looking at the children now, we see a ratio of 1, which is this one, to 2, which are these two, and 1, which is this one. So this is, I'm going to say homo-dom. This is hetero. I'm excluding zygous for writing's sake. And this is homo-recessive. So that is our genotypic ratio of something that follows Mendel's law, or you know, like it's typical Mendelian genetics, and that's something that you'll learn in genetics. Don't have to go over it now because it's a lot. It's a whole chapter you'll cover, don't worry. So that is how you do a monohybrid cross. However, and okay, and so that's our genotypic ratio. However, we should look and see, well, I want to know what what the children will look like, what characteristics they will express, which is what we call a phenotype. So this person would have brown eyes because, you know, big B, big B. This person, both these people would have brown eyes because the dominant allele has obviously dominance over this recessive allele. So those are expressed as brown eyes. But this person has both recessive alleles and they express blue eyes. So we'd see that as a 3-to-1 ratio, phenotypic ratio. And that's important. Usually with monohybrid crosses, this is what you will always see if it follows Mendelian genetics. But now it gets a little bit more complicated when you're working with dihybrid crosses. So here will be our dihybrid cross work. This you'll definitely see with P color and P shape. I guarantee it. But we're going to do some work with, we're going to say we are looking for a dihybrid cross of eye color and whether or not someone has a widow's peak. So let's say that widow's peak is a widow's peak is recessive to not having widow's peak. And then eye color, brown is equal to big B and blue is equal to little b. And for widow's peak, let's go no widow's peak is equal to big W, and widow's peak is equal to little w. So what we're doing with this is we want to see all the possibilities of doing a dihybrid cross. So this gets a little confusing and it can be very daunting, but I'm going to show you a trick for it that I always use. So to set up a dihybrid cross, it's a lot and it looks overwhelming, and it is overwhelming. It absolutely is, which is why I follow a very different way of doing it, but it's a very popular way to do it too. And so, you know, just bear with me and we'll get through it. So to set up a dihybrid cross, the big way, which I do not recommend, but I'm going to show you just a little part of it. Well, I'm going to show you the whole thing actually, so you can get a feel for the ratios and everything. So what you're going to do is you're going to do big B, big W, and you're going to follow that trend all the way through. So now we're going to do big B, little w, little b, big W, and little b, little w. And then we're just going to do the same thing here. There we go. It gets really confusing to keep up with, but it is what it is, you know? And now we're going to fill them in. So you take the B's, put them together, and the W's, put them together. Big B, big W, little w. And then I'm going to be right back with filling this out, and I will explain more in a second. Actually, just kidding. We're just going to go through it that way, because I hate when videos just cut through, and sometimes it's a little problematic, you know. Big B, little b, big W, big W. Let's see. And you know, it really does get confusing. Like, sometimes I like to just run through it like this because my mind processes it quicker like this. But, you know, everyone's different. Little w, big W, little w. Oh, look at that. See, even you gotta always check yourself because This is why you don't do this method, but I'm showing you it just so that way you know how, because it's an important skill to be able to have. Oh, look, we got some blue-eyed people finally. But they don't have a widow's peak. Oh, sad. I don't have a widow's peak, if any of you were wondering. But I don't really know many people that do have widow's peaks. Okay, almost done. Sorry for how long this is taking, but this is the problem of doing a Punnet Square like this. You can fast forward through this, you know, do what you want, because it is pretty ridiculous filling this entire thing out. I personally hate this. And then I also get confused because I see the letters all messed up. So that is how you fill out a dihybrid cross. And it looks like a lot, and it absolutely is a lot. So to deal with this, we kind of, so the question might ask you, what is the probability of a heterozygous, of a child who has a genotypic heterozygous brown eyes. That's kind of a weird way to say it, but you know, they'll ask you a more straightforward way. Who has a, and who, let's see, who has a widow's peak. So you could go through and look at all of this, but it's kind of ridiculous to do all that. Something that you should know about it is that there is always a 9-3 to 3-1 ratio, which I understand is a lot to handle, but they'll go over that more with you. But if you're asked this question, so you want to know people who are heterozygous for brown eyes and have a widow's peak. The quick thing that you can do is you set up your monohybrid crosses that we worked on earlier. So here is your heterozygous parents right here. Big B, big B. Let's just fill this out really quick. And this moves a lot faster. And then you have your widow's peak kid. So you want someone who has a widow's peak. And you're assuming that the parents are heterozygous. So you'd go big W, little w, big W, little w. And they'll give you information on whether or not the parents are heterozygous or not. But in this case, what I'm doing, yes, they are. So let's see. Okay, so instead of looking through all of this and trying to determine, all you have to do is, okay, heterozygous brown eyes, 1, 2 out of 4, 2 out of 4 times, and you want a widow's peak, and we know that's recessive, so that's 1/4. So that is equal to 3/16, and that is your probability for having a child who's heterozygous brown and brown eyes, and you know, has a widow peak. And that is how you do a dihybrid cross. And so definitely when you're talking about dihybrid crosses, you're probably going to be looking at, you'll be asked things about like laws of independent assortment and that stuff. Dr. Ned's Wiki, if you take genetics, or Dr. Adams will explain. So yeah, but that's how you do a monohybrid cross and a dihybrid cross, and a quick way to solve problems for a dihybrid cross. Thank you so much for watching. Yeah, that was my tutor tip.